Who did?
Okay, here we go. So we left off on Thursday. Left off on Thursday with graphing sine and cosine. And so let's just pick up where we left off. What's the amplitude of that? 2. What's the period? Pi. Horizontal shift. Vertical shift. So what I do is I first draw my vertical shift, and then I go up 2 and down 2 from there. So it goes all the way up to 3, it goes all the way down to -1. My period is pi, divide that into how many? Do I start at the min-max or at the center? Center? Do I go up or down? Up, because it's positive. And so there we have it. That's it. If you remember, it took us a while to learn how to do that, but now it's pretty straightforward. See if you can do D on your own. Try D on your own. Hit D as a horizontal shift. See if you can do it. Good luck. That's the horizontal shift. Positive pi over 2. Because that's what you plug in to make 0. So, I mean, So, technically, any sine or cosine function can be written as what we call a sinusoid. It can be all written in terms of sine, and the way that you figure out the horizontal shift is you take that bx minus c, whatever it is, and you set it equal to 0 and you solve. That tells you the horizontal shift. Remember, you guys, when we did circles, we did x plus 1 quantity squared plus y minus 8 quantity squared is equal to 16. And that's the equation for a circle. What was the center of that circle? -1, +8. It wasn't 1, -8. Okay? So it's the same type of principle that we're working with here. So as we look at this graph, you've identified what's the amplitude. 3. So amplitude is always positive because it's the distance it goes up or down from the axis. What's the vertical shift? There's no vertical shift. What's the period? Horizontal shift, pi over 2. So when I draw these, I generally draw 2 of them. Okay. So I have 0 as my vertical shift. So I'm just going to go up 3. I'm going to go down 3. I have my markings. I draw out 2 pi. I divide that up into 4 regions. Pi, pi over 2, pi over 4, or 3 pi over 2. Now, this cosine graph, does it start at the min or the max? The min, because it has a negative in front. So I start down here, and I cross through, and you can see that the graph is going to look like this. But it has a horizontal shift to it. So what I need to do is I need to take all those pieces and shift them pi over 2 or 1 tick mark over. So all these points go over that much. I don't care. You can put it doesn't matter to me. It's really up to you whether or not you put the original there or not. Kind of the parent function, so to speak. That's your graph then. We all good? Okay. So that's kind of a brief review of some things that we did in Trig. Now what we want to do is we want to get to just some relationship type pieces that you're going to have to see. And we want to simplify these. So we leave the graphs behind. We leave solving for, secant and stuff like that. And we move on to this, okay? A lot of times when you simplify trig identities, you got to rewrite in terms of sine and cosine. So this is sine of theta over 1 times 1 over sine of theta, which is 1. See how many you can do. How about this? When you get one, why don't you come put it on the board if you think you got one. Okay. Does anybody need to see these ones worked out that we have up there right now? Which one? D? E? Okay, let's watch E real quick. We'll try a few of these. 1 minus sine squared is cosine squared. And again, you guys, you're not going to be asked to do necessarily this problem when it comes to calculus. But will you have to know that 1 minus sine squared is cosine squared? Very possibly. So that's what we're trying to work through here, is recognizing these identities. So you have multiple ones here. Cosecant squared minus 1 is cotangent squared. You can find that from one of the identities written down. So now I'm going to multiply by the reciprocal. Cosine squared of theta over 1 times cotangent is, but I want to write in terms of sine and cosine. So cotangent is cosine over sine. So I multiply by reciprocal, I multiply by sine squared over cosine squared. And when you do that, you can see your cosines cancel. How about F? What'd you do? Let's factor out a sine squared. What's secant squared minus 1? Tangent squared. And tangent is sine squared over cosine squared. So when you multiply them, will the sine squareds cancel? Tangent squared, again, is sine squared over cosine squared. So will the sine squareds cancel? No, they won't. So you just leave it like that then. We're done. Anybody get G? CSC? Thank you. Is that where you're going to college? All right, great, cool. Who knows? He just made it up. Sine of theta over 1 plus cotangent is cosine over sine. So you're going to have cosine squared over sine. Because you have cosine over sine times cosine will be cosine squared. Yep. Yeah, make a common denominator. Sine so we got sine. So you get, what's sine squared plus cosine squared up top? 1 over sine CSE. Cosecant. Así hace muy mal. How about H? What's Solve? How'd you get it? Conjugate? Really? Good for you. Solve is correct. I'm going to show her an easier way to do it. I'm going to take cosine squared and I'm going to insert 1 minus sine squared. You might say, well, why would you do that, Mr. Gens? That just looks more confusing. Well, I recognize that if I factor 1 minus sine squared, I will get something to cancel, won't I? So what Solveig did was excellent. She created a sine squared on the bottom by multiplying by the conjugate. And when you create squareds, a lot of things substitute. Well, if you do this, yep, 1 minus sine of theta, 1 plus sine of theta, over sine of theta, plus 1. Actually, as I think about it, I think Solveig's way is probably about equal in terms of amount of effort. I don't think it's necessarily any longer, but 2 ways to see it. Always more than one approach. Whether you have negative sine of theta plus 1 or 1 minus sine of theta, doesn't matter. Let's try a few more. Tangent times cosecant over secant. What do you want to do? Well, okay, good. Sine of x over cosine of x times 1 over sine of x times multiplied by the reciprocal. What's the reciprocal? Cosine. Bada bing, bada bam, bada booski. I had a professor one time. He told me. He said, you know, he said, you probably learned by now that when you're in my class that when you're in doubt, a lot of times it looks good if you just write a 1 and put a box around it. You know, you got a good chance of getting the answer correct. So he said, you know. He even admitted, he said, one time he said, I was at the board and he said, I forgot how to do the problem. And I didn't want to look stupid in front of the class, so I wrote some stuff down and wrote a 1, put a box around it. Everybody was like, oh, yeah. No, you guys, I'll be 100% honest with you when I make mistakes. You know, at Chrissy's class, that was the first time I had pre-calculus come through, and I made, you know, there was a number of mistakes I made, or I hadn't read through the notes ahead of time and stuff, and so I definitely had to step aside sometimes. So, but well, what's 1 plus tangent squared? Secant squared. So you get sine squared times secant squared. Well, sine squared over 1, what's secant squared? That's 1 over, so you get sine squared of x over cosine squared of x, which is tangent squared of x. Who would have known that sine squared plus sine squared tangent squared ends up being tangent squared? Who would have thought? Try to see on your own. Try to see on your own. See what you can do. Go. I love T-bone steak. Gonna set it up like that. Find common denominators, multiply top and bottom by cosine. And you get cosine squared plus sine squared, which is 1 over cosine, which is SEC. SEC. Shh. How about D? What are you going to do for D? No, but we'll just go through this. Yeah, so we got cosine of x over 1 over cosine of x plus sine of x over cosine of x so I have cosine of x over 1 And I'm going to multiply by the reciprocal. The reciprocal would be cosine over 1 plus sine. So, oh, you thought, well, maybe the cosines will cancel. Well, they don't. You get cosine squared. Now, instead of cosine squared, what could I write instead? 1 minus sine squared over 1 plus sine of x. And does 1 minus sine squared factor? Yep. 1 minus sine of x is 1 plus sine of x. And fuego, that's what we say in Spanish. Yeah. Whoop. The C is for I. Correct, sorry. What do you think of that? Try E and F on your own. You can do it. You're really smart. Okay, so you FOIL, you get tangent squared minus secant squared, and you know that secant squared minus tangent squared is positive 1. So if you factor out negative 1, you do see that this is negative 1. And we'll give our last identity a shot. When I see something like this, you think you got it? Sine of x over cosine of x? So what would you do in this situation? I would try to make common denominators. And here's the reason why I say right away, you know, because some people started the last one turning sine and cosine. You know, you could see that you would get a squared, right? And when you see you get a squared, things tend to work out nicely because things will cancel. Well, if you just use a little bit of foresight here, everybody. If you use common denominators, that means you have to multiply top and bottom by cosine, top and bottom by... So, true or false, you get a sine squared here. You get a cosine squared here. And that ends up being 1. So, we know you're going to get some good stuff resulting here. So, let's just do it. 1 plus sine of x. Isn't it amazing last year when you went through some of it, you know, you kind of felt painful and you went through the test, you're like, oh, I couldn't do that. But really, it's, no, you guys are doing well. It's all coming back. Sine of x plus sine squared plus cosine squared all over cosine of x times 1 plus sine of x, right? Well, what's sine squared plus cosine squared? So you get 1 plus sine of x in the top, which will cancel with the bottom. You get 1 over cosine, which is secant. Awesome. All right. Are you ready for the last section? Casey likes this stuff. She says I would like a nice long assignment just like that, just on trig stuff. Come on. All right. Solving trigonometric equations. 3 sine of x is equal to negative 1. I subtract over the 4. Divide the 3. So sine of x is equal to negative 1/3. Do you remember what I do at this point? Before I inverse, I identify where sine is negative. Where is it negative? In the, no, third and fourth. I draw two reference angles, third and fourth. Sine has a value of negative 1/3 in both the third quadrant and the fourth. No need to use the negative when you actually do it on your calculator because we know we're there. Now, we are going to strictly work in radians and calculus, so let's work in radians right now. Turn my calculator on and go to mode. So sine inverse is how I get rid of sine. And we get about 0.34. Don't enter the negative. The negative is what you used to decide it was in the third and fourth quadrant. So if those are 0.34, what now? From yeah, so you have these markings. You got 3.14 and 6.28. And if we just add 0.34 onto 3.14, we get 3.48. And if you subtract 0.34 off of 0.28, you get 5.94. Yeah, and you know, if you don't believe that it works out like that, just go ahead and take sine of 3.48. You're going to see you come up with that that value that you wanted. Actually, we rounded. You know, trig values really like to go up to 4 decimal places, but we're not going to be that picky. So if you plug it in, it should work out. So what would you do with something like b? So you got secant squared of x is equal to 4. Square root it. Secant of x is equal to plus or minus 2. Can you do secant on your calculator? No, so we're going to instead do cosine is equal to plus or minus 1 over 2. Where's cosine positive? First and fourth. Or is it negative? Second and third. Now, I happen to know, I just want to show you a trick so you can understand. When you end up with a nice value like 1/2, go to the front of your unit circle. Where is cosine equal to 1/2 in radians? 5 pi over 3 as well as just pi over 3, right? As you look at your unit circle, if you follow, if you find pi over 3, cosine is equal to 1/2 at pi over 3, right? So, as opposed to going inverse on your calculator, you could just, do pi over 3. And, the answer looks nicer. Now, if you want to convert it to a decimal, that's fine. I mean, again, you could take out your calculator, and, you go second cosine inverse 0.5, and you get, that 1.04, which is, exactly what 3.14 divided by 3 is. But now it's in a nicer form, because now you got, this is pi over 3. This is 2 pi over 3. This is 4 pi over 3. This is 5 pi over 3. So those are your 4 solutions. And now they're exact as well. So I know that might not be just stuck right in your brain, that all those values are there. But it's important to recognize the unit circle and where those values work out nice. Anytime you come up with a half or like a square root of 3 over 3, stuff like that. Okay, one more, then I'm going to, you know, let you see what you can do on your own. Because we're out of time. What about for C? There's one mistake you can make right here that I would, you know, divide the tangent. Do not divide the tangent. You will lose solutions if you do that. Okay? Go like this. Tangent squared of x equal what? Plus 3 tangent of x is equal to 0. Now what? Factor out the tangent. So now you have two equations. First of all, where is tangent of x equal to 0? So 0 and pi, right? 0 pi and 2 pi. Okay. So if we're saying x is anywhere between 0 and 2 pi, there we go. And then tangent of x plus 3 equals 0. Then we're solving for a tangent of x is equal to negative 3. Where is tangent negative? Second and fourth. So now we go on our calculator, tangent inverse of 3, and you get 1.25. We're almost done. So how do I convert those to radians? Or how do I convert them to the actual degrees? Or how do I convert them to the actual answer? Subtract it off of 3.14. 3.14 minus 1.25 and 6.28 minus 1.25, and I get 5.03 and 1.89. So I'm not going to add any, you know, I would like it if you could try to work through the rest of these or a couple on your own. That'd be great. They're challenging. So, well, H isn't, but the others are actually pretty challenging. If you want to try, give it a shot, go ahead. But make sure you're caught up with your sign from 3-4, because tomorrow we move straight into 3-5, which is derivatives of trig functions. I hope you have a great day. It's been wonderful seeing you.